Okay, question 8. Show that 1 over 2 r plus 1 minus 1 over 2r plus 3 is that expression there. Well, it was 1 mark because there was nothing to it at all. To put it over a common denominator, we're going to do 2r plus 1 times 2r plus 3. That means we've multiplied the first fraction by 2r plus 3. We've multiplied the second fraction by 2r plus 1. There we are, that line gets you your mark. And then if you simplify the top line, you have 2r take away 2r and 3 take away 1. So we have 2 over 2r plus 1, 2r plus 3. Hence find. And I know what happens when you read this. You think, right, okay, we've done that. Must work fast. We're now going to do a method of differences based on that. And you read this, really, you don't even read this. You just kind of skim through that. And what happened was lots of people didn't notice that that 2 there has changed to a 1 up there. So it's not exactly the same thing that we're doing. So when we do part 2, we need to allow for that. Part 2, the sum as r goes from 1 to n of 1 over 2r plus 1 to r plus 3. Well, if that was a 2 on the top, we'd need a factor of a half in front of it. So that is equal to a half of the sum of 1 over 2r plus 1, take away the sum of 1 over 2r plus 3. And that half was a factor that lots of people missed. The mark scheme allowed you to get away with it not being there until the very, very end of the question. It was only the very last final answer that you lost a mark for not having that half in there. So if we put the values in, I'm going to keep it in there all the time. If we put the values in, we know that we need to write out this sum in such a way as it's obvious we know what it means. So that's 1 over 2 times 2 plus 1, that's 1 over 5. Take away 1 over 7. And then if we put 3 in there, we get 1 over 7, take away 1 over 9. 4 in there gives us 1 over 9, take away 1 over 11. And so it goes on. The last put 1, if we put in n minus 1 into that expression, we would get 2 lots of n minus 1, so that's 2n minus 2 plus 1, so that's minus 1. Have I got that right? And then we'd have a minus 1 over 2n plus 1 it must be, because we're adding 2 each time as we go across.
You haven't put r equals 1.
Sorry?
You haven't put r equals 1 in. You've gone straight for 2.
Oh, I've gone straight for 2. Oh, man. Oh, can we squeeze it in? That was... there, look, I can do it. And then it looked like I've always remembered it. Oh, I shouldn't have a plus. Yeah, if r is 1, we have a third minus a fifth. Sorry, I've done too many terms now, really, but it doesn't matter. And then the final one, thanks, Michael, is 1 over 2n plus 1, take away 1 over 2n plus 3. And that's the whole thing. All of that multiplied by a half. And then you need to not obliterate what you've got, but we need to show that these terms would cancel out. And so we'd be left with, now let's be careful, we've got a half here, times a third, minus 1 over 2n plus 3, as our final term. And the question said, giving your answer as a single fraction. So at the very end of all of this, we need to put this as being a single fraction. So this is a half. What we've got in here, if we put it over a common denominator, the common denominator would be a third times 2n plus 3. The first fraction we've multiplied by 2n plus 3. The second fraction we've multiplied by 3, which leaves us with a half times 2n over 3 lots of 2n plus 3. And actually you notice here that half that we had at the beginning just knocks out the 2 on the top, so we end up with n over 3 lots of 2n plus 3. Equally, n over 6n plus 9 was just as acceptable as the right answer. You didn't have to have that bottom line factorised. But there it is. You did have to put it as a single fraction at the end. However, having it as a single fraction at the end is not that useful for the next bit. It's better in that format for the next bit, because the next bit says, find the sum from, look here, we're going from n to infinity. We've still got that 1 on the top, but now we're going from n up to infinity. Giving your answer as a single fraction again. Right, so let's think through that bit. Is this part 3? The sum from n to infinity. Remember that's if we think of it going from 1 to infinity, can't quite reach infinity, but 1 from infinity, and then we're going to take away the bit that we don't want. That's how we work these out. So that is the sum as we go from 1 to infinity minus, so the bit that we're going to take out, we need to be starting at n, so we need to go up to n minus 1 when we take a bit out. That is from 1 to n minus 1 that we're going to subtract. So we need to think, what does that look like as a sum? Well, that is 1 to infinity. Hang on, where am I going with this? 1 to infinity, yeah. It's helpful, where was it? To go right back to that expression there. If you imagine infinity going into that expression there, you're left with a half times a third, take away 1 over something that is kind of double infinity plus a little bit. So that's 1 over something massive would be 0. That term would go to 0. You're left with a half times a third. So we're left with a sixth as being that amount. And then we're going to take away the other bit. Notice how it's easier to look at the pre-brought together fraction than it is to look at that one. That one's a bit harder to see that it's going to give us a sixth, isn't it? You can, because you can kind of imagine it as being, it's that plus 9 that we've got becomes insignificant, so you end up with infinity over 6 times infinity. The plus 9 is neither here nor there, and so that's, if the infinities cancel out, it's 1 over 6. It's a slightly old way of thinking about it. It's better to think about the two fractions. So this one, we've now got to replace this formula with n minus 1, so that is n minus 1 over 3 lots of 2 n minus 1 plus 3. That's an important step to get to. We've now got to put this eventually just as a single fraction, so that's just sorting out the algebra. That's n minus 1 over, what is all of that? That is 2n, take away 1, so it's 3 lots of 2n, is that 3 lots of 2n plus 1? Plus 1 it would be, wouldn't it? In there, because we'd have a minus 2 plus 3 gives us the plus 1. We need to put it over a common thing. So the common denominator is going to be 6 lots of 2n plus 1. Is that a sensible way of doing this? Which means that the first fraction, we've multiplied top and bottom by 2n plus 1. And the second fraction, we've multiplied top and bottom by 2. Because I've gone from having 3 lots of 2n plus 1 to having 6 lots of 2n plus 1. So that's 2 times n minus 1 on the top. If I simplify the top line now, I have 2n, take away 2n, that cancels out. I have 1 minus minus 1, so I have 2 over 6 lots of 2n plus 1, or 1 over 3 lots of 2n plus 1. That's my final answer. That's not the correct answer. Which bit have I done wrong? Oh, yeah, because I've done 1 plus 2 equals 2. Did you notice that? 1 plus 2 is actually more often equal to 3. Little known fact there. So that makes that a 2 on the bottom. There we are. Nice recovery at the end. Have I done that right now? Yes, I'm happy. Right, and that's correct maths.